Hello everyone. Today I wanted to talk about something about transformers, why we use high voltage in power transmission lines. Okay, so that's the topic which I have taken today. So let's look at this problem. Even though the problem might look a little bit lengthy and complicated, it's actually a very easy one, simple formulas. So what they say is a small town with demand 800 kilowatt. So 800 kilowatt is the requirement of the town at 220 volt supply. Is situated 15 kilometers away from an electric plant generator. So the power plant is somewhere here. So it's like 15 kilometers between the power plant and the town. And they are given the resistance details here. And then they are given the step down transformer 4000 volt. Again, this diagram is not given in the question, but it's a standard diagram you should try to remember so that you can plug in the data in the appropriate places. Estimate the line power loss and voltage drop. Very important. All the other things are also important, but mainly I would say these two things are what we are very much interested. And then the power loss percentage. So here there is a output and then there is a input here. So in these kind of problems, I would say you should start from the right side instead of, you don't have much information on this side. So you have to start from this side. So the reason I say this is, let's say if you are, assume an ideal transformer, P in is equal to P out, power in is equal to power out. Why? In a law of conservation of energy, energy in is equal to energy out. So on this side, if I write it as voltage into current is equal to this 800 kilowatt, sorry. So V is given as 4000. So since that means I can calculate it as 200 amps. So 200 is a pretty large current. So why are we interested in this current? Because that is the current which is flowing in this transmission lines. How do I calculate the power loss? P loss is equal to I squared R. So that means 200 square into 15 ohms. Why 15 ohms? Because they said two wires. So 0.5 ohms for one wire. So that means 1 ohms for two wires. And then 15 kilometers, so 15 ohms. So if I do this math, I'll be getting 600 kilowatt. You see, it's a very simple problem if you understand the basics here. So the power loss is 600 kilowatt. What that means is I cannot supply 800, the power station cannot supply 800 kilowatt. Why? Because if I supply 800 kilowatt here, by the time it reaches to the town, it will be 800 minus 600, which means I'll be getting only 200 kilowatt, which is not acceptable. So that means what we do is the loss should be added. So that means 800 plus 600. So I have to supply 1400 kilowatt. So if you supply 1400 kilowatt, 600 kilowatt will be lost and 800 kilowatt will be available in the town. So that means that is power to be supplied by the power plant. Okay. So we calculated the power loss and then power to be supplied by the power plant. And power loss percentage, it's very easy. Loss percentage. So it's like 600 is lost and 1400 is supplied. So do the math over here. So I think you should be getting around 43%. Can check that out. So that means the loss percentage, power loss percentage is 43%. So that's a huge number. Okay, so definitely this is not acceptable, but still, as a numerical problem, we should understand, I'll tell you why this problem is given. And then voltage drop. So 4000 volt is coming here. So we drop along this region. We drop is equal to I into R. I we already calculated as 200 amps. I told you it's a pretty huge current. R is, we know it's 15 ohms. So do the math and you will get 3000 volt. So that means the voltage drop is 3000 volt, which means in order for me to get 4000 volt here, I have to supply 4000 plus 3000. So that means I should be supplying 7000 volt here. So it means 7000 volt should be supplied at this point. So read the question here. Generating power at 440 volts. So that means this is giving you voltage at 440 volts. So that means the step up will be converting it to 7000 volts. Okay, so I think we pretty much answered all the questions. That is the configuration 440 to 7000. Again, as I said, you should start from the right side. So from here, you have more data on this side. You don't have much of information here. So that means you have to start from here. Okay, so same thing, whatever I worked it out, I've given it here in a typewritten format. And usually, after giving this problem, they are given this problem. Do the same exercise as before with the replacement of earlier transformer by a 40,000 to 20 volt step down transformer. So that means instead of 4000 volt to 20, this is 40,000 to 220. So hence explain why high voltage transmission is preferred. So the purpose of this presentation is to get back to this point, why we are using high voltage. So if we repeat the same problem with this new information, you will be getting something like this. So this is the first problem which we already solved, and this is the second problem. So here 800 kilowatt is same. Instead of 4000 volt, you have 40,000 volt, which means instead of 200 amps, I'll be getting 20 amps. The power loss in cable, which is I squared R losses, instead of 200 square, I'll be getting 20 square. So that means instead of 600 kilowatt, I'm getting 6 kilowatt, which is pretty huge difference or huge reduction in power loss. So now instead of supplying 800 plus 600, I will be supplying only 800 plus 6 kilowatt. It means only 806 kilowatt is supplied at the power station. So 6 kilowatt is lost out of 806, which means I'm getting 0.74 percentage. So look at this. Here I'm losing 43%. Here I'm losing only 0.74%. So you can see that definitely this is not acceptable and this is acceptable. Similarly, you can calculate the voltage drop. So the point we are trying to make here is how did we achieve this? Because current was, instead of using 200 amps, we were using the current of 20 amps in this transmission lines. How was that possible? Because we were using 40,000 volts here. So 40,000 plus 300 volt drop. So 40,000, 300 volt is the voltage which this is coming through here. Okay. So because of that, we were able to reduce the power loss. That's also, that's the important point we are trying to make here. So the important takeaway here is during electric power transmission, voltage is kept very high and current very low. So that power loss, which is also called as I squared R losses, is very low and voltage drop is also very low. As I is small, cables in the support structures can be smaller and less expensive. Okay, I hope that makes sense. And this is just a general diagram to show you, how the power transmission happens. And don't forget, transformers will work only with alternating current. It will not work with direct current because there is no changing current on the primary side in a DC current. So only in alternating current, you will get a alternating current on the secondary side also. I hope you learned something in this video. So thank you very much.